So now we're going to focus on trig values that are not on the unit circle, meaning I do not have a radius of 1, not on the unit circle. So what we want to do is fill in the ratios for our angle theta in standard position, given a point xy on the circle, okay, and it's on the terminal side of theta, and this is also on the circle of x squared plus y squared is equal to r squared, and this is not a unit circle, meaning my radius is not 1. So here I have my point xy, okay, and we know that we're looking for theta. All right, so again, your adjacent is going to be your x, and your opposite is going to be your y. So this is very similar to what we did, but the biggest thing that you need to remember here is that you are not on the unit circle. So you still have the sine of theta being your y, or essentially your y over your radius. So the reason why I didn't have to write this before up here is because my radius was 1. Okay, now my radius isn't 1, so I have to write it as y over r, whatever my radius is. So this would be x over r, and this is still y over x. Okay, so when I flip this over, this is r over y for the reciprocal, r over x, and this is x over y. Again, you cannot disregard r because you're not on the unit circle, so r is not equal to 1. So one thing I want to point out to you, you'll still be using your SOHCAHTOA relationships, but here there are some common triples that you need to remember from geometry. So you have a 3, 4, 5, which if you double is 6, 8, 10, or if you cut this in half, it's 3 halves, 4 halves, 5 halves, and I know that this is 2. Okay? Some additional common triples are 8, 15, 17, 5, 12, 13, and then 10, 24, 26, which is a variation of the 5, 12, 13. These are worth committing to memory. However, if you know the Pythagorean, you should be okay. So again, trig values not on the unit circle. So now what we want to look at is that we are given the directions of the following. A point on the terminal side of the angle theta, find the exact value of the trig functions. Okay, so we're going to do this example right here, and what we're going to take a look at is this on the unit circle? So if I take a look, I know this is x and this is y. So if I locate this on the circle, okay, my point is at -1, -2, all right? So here we have -1, -2. I would put my point out here. Here's my radius. I drop down my y. Here's my right angle. Okay, I'm talking about theta being right here. Okay, so what we're saying is this is -1, this is -2. Always draw the triangle. So now if I use a Pythagorean, we would say that x squared, which is 1, plus y squared, which is 4, is equal to r squared. So what that means is that r is equal to the square root of 5. Now, typically when you take the square root, you would say plus or minus, but a radius cannot be negative. Therefore, this value is the square root of 5. Now that I have my triangle drawn on my circle, I can now find all 6 trig functions. So I'm just going to say sine of theta, cosine of theta, tangent of theta. Sine, remember, is y over r. So this is my y value, this is my r value. So when you rationalize -2 over the square root of 5, this becomes -2 square root of 5 over 5. Cosine of theta, -1 over the square root of 5, which is negative square root of 5 over 5. Tangent is y over x. Y over x. This is just 2. These are my basic. Now I need to find the reciprocals. So this would be the cosecant of theta, secant of theta, cotangent of theta. So here, if this is y over r, this would be r over y. So it's the square root of 5 over -2. It does not matter where the negative is. Here the secant is the reciprocal. So if this is x over r, this is r over x. So r is the square root of 5 over -1 or negative square root of 5. and then the cotangent is the reciprocal of the tangent, which would be 1/2. Okay, when we state, again, exact values, this means no calculators, no calculators. Okay, last piece. So sometimes what you will be given is an angle, oftentimes a special angle, or it might not be a special angle from the unit circle, but once you evaluate, it will become a special angle, and you will be looking for exact values, meaning we want you to find something on the unit circle. So here you're given that f of theta is the sine, and g of theta is the cosine, and theta is 60 degrees. You're told not to use a calculator. Okay, so what you do is make sure you watch the order of operations. Okay, so what we want to think about is highlighting where we have a theta, okay, and then we are going to plug in theta wherever you see it. So essentially what this is g of theta squared. So what we could say is g of 60 squared, 60 degrees squared, and the g is the cosine. So essentially, if I go down in this direction, this would be the cosine of theta squared. Okay. These are the same thing. I'm just showing you two different ways to look at it. Okay, cosine of theta. Okay, now I plug in my 60. Okay, because we know what theta is. Okay, so theta right here, 60 degrees. So this is cosine of 60 degrees squared. We know what this is. The cosine of 60 degrees from the unit circle is 1/2. 1/2 squared is equal to 1/4. Okay?